All right, now let's continue. Let's continue. What else are we doing now? Have you guys finished the dispersion forces and all that stuff? What else do we have to do? Anybody? I think we actually did in the last film, in the last review, we did hybridization and molecular orbitals. What else is there? What did you guys do over there?
We did the polar.
All right, polar, nonpolar. Okay, so let's do one really quickly. We'll do polar, nonpolar. Yes? Okay, so this is CH3Cl, and we're going to say 1, 1, 1, 1, 1, 1, and then 7, and then 4, which is 14. No, is that right? Yeah, which is 3 plus 11 is 14. Correct? Yes? So then you take 14 minus 8 is what? 6. The hydrogens are satisfied, so you get this. Now, you look at the electronegativity table. You're going to need your own electronegativity table copied onto your notes. You're going to get this. These are balanced. These are not. Polar. Clear? What shape is this? What shape is this going to be? No, 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 no. No unbonded pairs. 4 bonded pairs, no unbonded pairs. What's it going to be? Come on, guys, you can do this. This is a little disturbing. It'll be tetrahedral, right? It's a little disturbing. Okay? Tetrahedral, yes or no? Okay? Polar, right? What's the difference between polar and nonpolar? Here's a great example. The polar molecules, not polar bonds. A polar bond is anything with 2 different elements on it. The nonpolar bonds, the polar molecules will have slightly positive one end, slightly negative the other end. Okay. But what about the melting points of nonpolar versus polar? Yeah. Like, let's look at the nonpolar. Methane. Methane. Let's look at a polar. Go ahead. Okay, that's water. Okay, that's water. Nonpolar methane. What about the melting point of water versus methane? Very low melting point, right? Very low boiling point, right? High melting and boiling point. This is water. This is methane. Be able to take any, so polar, nonpolar, yes, easy. Balanced, not balanced, yes. Be able to take any substance okay, let's do one. I don't know if this is even on the sheet, so this will be a good one. Xenon tetrafluoride. Yes, noble gases can form substances. It's weird, I know. Xenon tetrafluoride. Be able to do any, and I'm talking about any molecular model. Shall we do xenon tetrafluoride? Have you done that yet? Has anybody seen it? Good. What's the total valence? Let's go quickly. What's xenon? You got to look at the periodic table. 8, right? What's fluorine? 28. Augustina, very good. 28. She automatically did the multiplication. I like that. Did anybody ever tell you your brain's like a computer bank? You know, Michael complained one day. Said, you know, Mr. Darcy, can you change my seat because I hear this clicking coming from her brain all the time. And that's because she's like a computer upstairs. She's like a computer. Okay? All right. You know, in Argentina, her nickname is computador. Okay, that's her nickname. Okay. So, 636, yes? 36? So I got this. FXE, F. Sorry, losing my mind here. Where can I put this? Can I erase this? And I'll just put 36 here. So I'll make it like this. Okay? Yes? Okay. So now 36 minus 8 is what? What is it?
No, not 24. 20.
I know that. Michael, that was very facetious. I like that. I like that. Okay. That's, somebody's trying to get it. It's Michael Luna is trying to get it. He can't get the answer. No, just want to say that on the air. No. Okay, I'm sorry. 28, right? Okay, 28. 28, right? Now. So I want to take and I want to put 6 around each of these, right? So 6 times 4 is 28, right? See what you're doing to me? 6 times 4 is 24, right? That gives you 4. Where do you put them? Yes. Around the center. 2 pairs, right? So what is that? What's the molecular model? And is it polar or nonpolar? See, it has excess electrons. It has non-bonded electrons on the central atom. So you're going to right away think, irregular geometry, polar. And I'm going to say, wrong. What's the geometry? What's the name of it? Come on, guys. He says tetrahedral. He says that a lot. I know. He just throws that out there thinking one day it'll be the right answer. Okay. I asked you what 2 times 4 was, and he said tetrahedral. No, that's wrong too. Okay. Yeah, that's the right answer to 8 questions in all of chemistry. So be careful, Aaron, before you start throwing around that word, okay? I'm going to charge you tetrahedral tax, okay? Yes? Augustina, you are a computer, I'm telling you. Square planar. Look it up right now, everybody. Square planar. Square planar. So it looks like this. It has, all right, I'll use these things as actual, well, I'll put them as pairs, I guess. Could somebody bring me up? I have some right here. Excuse me. So it looks like this. This is opposite. And this goes like this, perpendicular. And this one. Blah. Yeah. See that? Okay, can you see that? Does that come up good? Yes? See that? The 2 extra pairs, the 2 non-bonded pairs. These are non-bonded. These are bonded. See that? Square planar. Polar or non-polar? Polar. That's right. Polar. Okay? Polar. Give me a scenario where that wouldn't be polar. I'm sorry. Give me a scenario where that would be polar. Anybody? If I said this, something like that. It's kind of weird looking, isn't it? So in other words, if I took one of these off and I put a BR in there, that would be polar, right? Yes? Because these would not cancel. Yes? But if I have this, non-polar, yes? What would you expect the melting point to be for that? Low, right? Right, yeah. But maybe not that low. Why? Because there are some extra electrons here, so you might get some you know, things going on there. All right? So that's that's on. Now, what have we got to do? So on Sunday, on Sunday, you guys are up. You four back there, and I want to know everything there is to know. Remember, look up Van der Waals force. I'm going to give you some homework. This homework, you're going to say, after you take your test, you're going to say to me 2 words. You ready? You know what the words are? Thank you. Okay? Did you just have an episode with your stomach? I was wondering what that noise was. So, look up dispersion forces, Van der Waals forces, London forces. Very cool. Okay? And that's it. This is review part 3. I'm going to make 4 parts. And I'm going to go home tonight and make a test review. I've already made up the test. Really cool. Okay? Are you there? Are we there? Yeah? Okay, bye.